Hello, I'd like to show you my VGA add-on for Warren Toomey's Crazy Small Computer VGA. This is another 8-bit computer without a microprocessor like the Gigatron and Ben Eater's breadboard computer. It's got 16-bit bus here, 8-bit bus here. What I do is I take the 25.175 megahertz crystal, divide that by 4 with this counter to give me a 6.3 megahertz signal. This then goes into these two counters here, which basically produce the x coordinates, and these three counters here gives me the y coordinates. These feed into this ROM chip here, which then gives me the control signals to reset the x and y coordinates when it gets to the right counts, and also produce the horizontal and vertical signals, as well as a signal to say whether the pixel is visible or not. So that basically produces all the control signals. Here we've got some bus transceivers, which when the clock is high will output the x and y coordinates into the RAM here, which is a high speed 15 nanosecond RAM. So that will address the RAM. The RAM contents will then be latched onto this register here, and then it goes through this ROM chip, which then decodes the pixel data and then outputs through a register DAC out to the VGA, which you can't see, which is up there somewhere. So that's how it outputs the signals. It also, I've got a register here which latches the horizontal vertical sync and the blanking signal to keep it nice in sync with the pixel data, which makes it a lot easier. Here we got two logic gates. There's an OR gate and an inverter, and together they take the signals from the CPU, the read and the write signal here, plus the most significant bit of the address, to work out whether to write or to read from the RAM at any point. To write to the RAM, I've used a very simple interface. It just has two latches here for the address and one latch for the data. So you put the address of the pixel on the address bus, the pixel data on the data bus. You say write, it writes them into these registers. It doesn't go into RAM, it just goes into these registers. Now, as I said, when the clock is high, it reads from the RAM and outputs the pixel to the screen. When the clock goes low, it reads from those three registers. So it gets the address and the data and puts it into the RAM. So as long as you don't change these, it will just copy the same data in on every clock cycle. But that doesn't matter because it's the same data each time. But you have to make sure that when you go to a new address, new data, it has to happen simultaneously, so it doesn't overwrite anything you don't need to. So that was like the simplest interface I could think of, without lots of logic and other stuff. I've also, to read back from the RAM, I found that was too complicated to do. So what I did is I added another RAM chip. So this is another 32K RAM chip, and this is the read signal here. So when you read from here, you put the address on there, you read on there. and it just outputs it straight onto the data bus. So that's nice and simple. The only thing I haven't explained is this chip over here. This is what I call the background color. You can set a background color. Now, normally a pixel would have one of 64 colors, just like the Gigatron. 2 bits for red, 2 bits for green, 2 bits for blue. But because I'm using a decoder ROM here, I've got a special mode where if the top bit is set of the pixel data, then it interprets the pixels or the data for the pixels slightly differently. And I use this for a text mode. So what it does is it breaks a pixel up into 4 equal squares, so it effectively doubles the resolution. So you can have one color as a foreground and another color as a background. There aren't enough pixels, enough bits in the pixel data to give you both the foreground and background pixels. So what I do is I have 3 bits for the foreground color, and then on the next 4 bits tells you which sort of sub-pixel, 1 of 4 is on or off. So in that one sort of normal pixel size, you can have 4 pixels, but they can only be the one color of the foreground and one color of the background. Now the background color is a bit more complicated because I can't do that in the actual pixel data. I have to do it somewhere else. So what I do is, if the most significant bit of the pixel data is a 0 and the next one is a 1, then instead of it does actually output it in that color. The next 6 bits gives you one of 64 colors, but it also stores it in this register here, which is the background color, so that whenever it does any of the higher resolution pixels, it uses the data in there as the background color. But of course, you can only you can't do that on pixel by pixel. So 2 adjacent pixels, you can't change the background color. You have to have a pixel in between, which is a normal size 160 by 120 size pixel, to change the background color. But that's just the compromise you have to make keep things simple and manageable and easy to build. So that's basically my VGA card. Hope you found this interesting, and give me any comments or anything at all, and have a look at the links I put on the video. Thanks.